Good morning, everybody. My name is Todd Eastman. Today I'll be presenting my 909 project, and it entails working with Landsat scenery, and it was a Python toolbox developed to help automate that. So we'll dive right in. A little bit about myself when I'm not at school. I've been a rocket scientist for 33 years, and I've probably launched over 30 satellites on our small launch vehicles, and but none of these. So we'll talk about Landsat. So the Landsat satellites started in 1972, and it's the longest running Earth observation set of data we have to date. And so it's actually proposed back in 1966 by Stuart Udall that NASA would take over and they would launch these Earth observation satellite for everybody. And so anyway, that happened, and you can see that there's been quite a few launches since then, and we're already at Landsat 9, and they're planning some new Landsat launches here pretty soon. So to get access to the Landsat data, it's now free. It didn't used to be free. In the 1980s, I think total sales to other governments and universities totaled around $4 million. But in 2008, it was decided that the data would be free. And so users can actually gain access to that by going to the USGS website or the Earth Explorer site. And anyone can create an account, and you can download your own data for free. So anyway, that's what a lot of people do these days, and it's a little bit of a manual process. You have to go in and input your coordinates and figure out what scenes you want, but it's available. So during one of the courses here, the grad courses, the 6-1B, which is a raster analysis course, I was doing an analysis of the Yellowstone fire, and that required some download of scenes from the Earth, the Landsat database. And as you can see there on bullet 4, those are the different names of files you get to download. So they're little, not intuitive, and it was lucky that one scene actually covered the whole Yellowstone area, but that may not always be the case. And so, these downloads can be repetitive. You have to have really good data management skills to keep track of, the file names and what they are. And anyway, it was sort of the impetus that I said, there should be an easier way to do this. And that's what led me to this project. So I searched the internet for what's out there, and there's actually a really good tool. It's on GitHub. It's called Landsat Explorer. It provides a API interface to the Landsat database. After you create your account, you just input a lat-long coordinate and a date, and it will actually give you available scenes that are in the database. So not actually without downloading them, just the information, what's there. And then the user can then subsequently download that information later. So that's pretty nice. It's Python based, and you can do that. But again, if you have multiple scenes and you have to stitch them together, it's still a little bit manual and a little difficult. And so to help simplify that, I created this tool I call Landsat Automated Scene Selection Toolbox. And it pretty much helps take all the sort of the repetitive nature out of the loop for the user. Okay, so to get started, there are some prerequisites. I did use the Landsat Explorer tool, and it's a Python tool. And so to not corrupt the Python environment, you first have to clone your own environment, because if you sort of corrupt the Python environment, ArcGIS is not going to be very useful. And so they make sure that you create a copy and clone that. So there's some instructions here in the third bullet for cloning Python environments. I'm not going to go into the details there. But after I did that, you can then do a pip install of that Landsat Explorer tool, and then now you have an interface to the data. And that was I definitely made use of existing software instead of rewriting that myself. Okay, so getting into ArcGIS, just went through the GUI, created a new toolbox. It self-populates a user interface for inputs and outputs, and then it's up to the user to fill in the guts and the meat of what those functions do. And so, um, it's a pretty intuitive process. It's pretty simple with ArcGIS. And I decided to create some inputs, whether it be date and different features. And at the end, the output it's an ArcGIS data type called the Mosaic data set, which actually can house just various rasters and various different rasters at different time lapses. So it could actually do a time lapse analysis. Okay, so here's the toolbox inputs. On the left, is an input feature in light blue. And that could be a point, a line, a polygon. It could be another raster. Doesn't really matter what the feature is. Um, that's your main input that you want to analyze, whether it be a city or maybe a state. And then another input is date. Okay, so let's talk about date a little bit. So the date, if you want something on, say, July 4th of 2020, the satellite may not have launched or flew over exactly on that day at that time. And so to really help the user figure out what type of, input they want, I had this other selector called nearest before and after. And so nearest will just give you the scene that's nearest to that date, whether it be before or after. And then before means that it'll give you the nearest scene before that date, just not after. And then vice versa after, it'll only give you a scene after. It sounds a little repetitive in nature, but if you're dealing with like a fire analysis where the fire started on a certain day, you definitely don't want the nearest scene that's after the fire if you were looking for it before. So that was really important to give that sort of detailed feature. The next input is a buffer length. So say you're looking at Denver, Colorado, and really you want to get a raster of information 100 miles, buffered from the center of Denver. Or actually, the inputs here are meters, but that allow you to sort of, extend that area of interest. Max cloud cover, if it's a cloudy day, but it's nearest the date you want, and you don't want that, cloudy scene, it'll select the next closest scene that passes that percent cloud cover. And then again, the output's a Mosaic data set. Okay, a little bit about the methodology. On scene one, you input the feature, what the tool does behind the scene. It's going to buffer that feature. Here we have Nevada buffered by a certain amount of kilometers. And then the tool overlay this fishnet grid. That's still not good enough because the tool needs points. And so we take the centroids of all those grid points on step 4. And now we have a list of points that we could send to the toolbox. But if we sent all those points that are outside Nevada, that would pretty be a waste of time. So the next thing we do is we go ahead and clip the centroids. And you can see on step 5 here, we have a clip set of centroids. And then those are the available points that we could send to the Landsat Explore tool to search the database. So in step 6, what we do is we'll input a point. Say we got the polygon that's in green back from the data from the server. Well, it extends over some other points. And so there's no need to then re-request those points to the database. So those get sort of flagged as not being available to be requested. So our whole goal here is to sort of minimize how many points that we interact with the database to sort of make it a little faster. Those points that come back, they really are, they're not the full scene itself. They're just metadata. They're JSON information that you can then grab like lat long points. And so what I did with that is created GeoJSON objects from that so that you can mask out the different points on the map that don't need to be researched. And that really gave a big speed improvement for the overall tool. It gave us a unique set of points that don't overlap and the minimum set that would be requested in order to sort of bound the user space. The tool then it will download those points. That's done in parallel processing because they're pretty much tar files that can be extracted and untarred, and they're very independent. There's nothing that depends on one another. So it's a great parallel processing. So with that sort of part of the tool, I got to about 10 seconds per scene download time on average. So. And then you put all those scenes into Mosaic data set and return that back to the end user. I'm going to go through a couple examples here. The first point here was Salt Lake City. The way this happened to work is the scene on the bottom was selected first. I'm sorry, the scene on the top was selected first. And then because it didn't completely bound the blue space of the buffered space, it actually had to download a couple another scene. So there is some optimization that could be done in this tool to further improve it, because really all you had to do is download scene number 2 that's on the bottom, and that would have encompassed the space. Another test case I worked through was like the Colorado River. I figure if someone's doing analysis of maybe some riparian areas of the river or wants to know what type of vegetation, this is another feature type. And so you could see the tool went ahead and it downloaded the appropriate scenes to bound the river. Okay, another test case was Nevada again, a polygon where it just shows that the necessary scenes to bound the sort of the buffered area that was requested in the dark blue. Okay, I really felt like the project itself was successful. Learned a lot about Python and working with ArcGIS and Landsat imagery. There's a few things that I'd like to maybe improve upon in the future. I'd like to do away with sort of that Landsat Explorer pip install tool. It really complicates the user interface, and it would make it very little more difficult and challenging for other people to take this tool and utilize it. It's just one of those things that seems like it'd make it a lot simpler. Also, that sort of selecting of scenes by percent coverage, it seems like we could sort of automate that and get that a little bit better in terms of how that works, just to help sort of prioritize the scenes in terms of their coverage and not have to duplicate any downloads that are not necessary. Also, to convert the data right now, it's just in raw data. So really, we would want to convert it from raw data to from radiance to reflectance, top of the atmosphere reflectance. And from that point, then, we could use a lot of different indices to analyze things about the Earth, whether that burn ratios or vegetative indices. And so that's and all the metadata is available there. It's just some time and it would take to implement that. And then the last thing is the Mosaic data sets. From what I read, they're quite useful in terms of being able to handle a time series analysis. And I think that would be really cool to be able to analyze a tool with a date range and sort of see how things change over time. So with that, I have a last page here. It actually is a little video of me going through the tool, inputting, this is the Colorado River feature, asking for a certain date. And here I'm picking the nearest sort of feature. And then it'll go through and it'll start to download scenes, here pretty shortly. Pretty much what it's doing right now is just, buffering the river, and it's figuring out, which scenes and grid points necessary to sort of bound this. But while this is going on, I figured I'd open it up for questions if anyone had any questions. So, these are just the GeoJSON polygons that are created from the API data that is downloaded. They're not the full scenes because this is just the selection process. And so during that time, you really don't want to burden the server or your bandwidth with actually downloading the scenes, because the scenes then are quite large. But you can ask the server for just some JSON data of that and describe that first. Anyway, that's the tool, how it works.